button. So I'm clicking on the record button. So it's right now recording. So I need to actually post my lecture on the web page or copy my lecture to this new PC here. So then I will be able to teach you the topic. So it's very simple. I'll be completing the lecture quickly enough so that effectively I'll complete the chapter today. So like we always do that, it is a lecture number 8, because lecture number 7 was the before the midterm exam, right? That was before the midterm exam. So I'm copying the lecture here to let you see it. So lecture number 8, I put it here. Excellent, excellent, excellent. Is it that fast? Yeah, it is that fast. It copied that fast. USB. Good, good, good. I just take this one here and then put that here to copy. Here. Okay, okay. All right. So that's auto pay. Continue without scanning. File Explorer. Sharing my screen with you in a minute. Lecture 8. IRR and cash flow. This is what it is, topic. I'm sharing my screen with you. Sharing the screen with you. You see my screen right now, right? I'm opening my lecture notes. So, and what, any question here? Yeah, good, good, good. So I'm closing the video panel. Closing the video panel. And also the floating. This is a new one. I never needed to use it actually to close it, but it is a good thing. Okay, all right. So I open the lecture here. So this is what we are supposed to do today. Okay, lecture 6A7 is not really like a lecture, it was a midterm exam. So week 7 was like a midterm exam. And annual cash flow analysis. That's what it is. Technically speaking, I could have given you a holiday today because it's 1 week is considered to be the midterm exam. So which means that we'll probably finish it a class before. So annual cash flow analysis. Cash flows in the forward direction, and it can also flow into the backward direction. And you want to analyze what's going on, a yearly movement of the cash flows. Basically, cash flow is normally regarded as cash in minus cash out. Cash is coming inside your company and cash is going outside your company. In minus out is the cash flow. So effectively, you could see revenues coming in. So investments go out, the expenses go out. So you will actually take those investments and expenses into consideration, and then the revenue is coming in, so that kind of thing is cash flow. So you want to understand the annual cash flows and the actual worth of it, because today's dollar is not the same as tomorrow's dollar. So you know what, there are so many ways of evaluating equal life scenario, unequal life scenario, continuous life scenario means permanent solutions. So a bridge is supposed to be like a permanent thing. Okay, present worth analysis, NPV, net present value analysis, and the annual cash flow analysis. So we already covered these topics here, to be honest with you. And we will look at a new perspective, other perspective, salvage value. Can anyone tell me what is salvage value, please?
That we can recover at the end.
Yeah, at the end, there is a terminal value of for everything. That's called salvage value. For example, you bought a car and you decided one day that you don't want to use the car anymore. What will you do? You throw in the garbage? No, you will sell it up in the market. Do you agree with me? You will put it on the market because you don't need that anymore. The car that you bought, that after some time, you don't need that anymore. You would like to use it for 5 years, you would like to use it for 10 years. It's up to you. And after, once you decided you don't want to use it anymore, you will sell that and you recover some money. That is called salvage value. Salvage value is the terminal value of an asset. Okay? So, which could be a machine, it could be anything. It could be a car, it could be anything. Even a banana, you're selling a bananas or tomatoes and potatoes. So before they become bad or expiry date, you will you will get rid of them for a lower price. Obviously, there is a price of each item, price of an item, a cost of an item, and salvage value of an item. You understand me? Each item you are selling, there's a price, there's a cost. The profit that you make equal to price minus cost. If you sell it, do you agree with me? When do you make a profit? When you sell an item. Suppose you cannot sell an item, you lose money. Okay, lose money. How do you lose? Cost minus salvage value. You understand me? So there is a shortage cost. Is also called as underage cost. Under age. This is shortage. That is price minus cost. What you lose is price minus cost. If you don't have an item with you. Okay? So what you lose, if something is excess, that means you are not able to sell the item, or overage cost is also called as overage cost, is cost minus salvage value. So how many items should you buy? I can precisely tell you based on this logic here. But unfortunately, it's not part of this course. Okay? And if you understand the demand pattern follows normal distribution, Poisson distribution, okay, or uniform distribution. If you tell me the distribution, I'll be able to tell you exactly how many items should you buy so that you will sell, you will not lose money. It won't be shortage, it won't be excess. So you also want to understand the rate of return here. You're making money, okay, your salvage, and then you want to understand the rate of return. Okay, annual cash flow. You stop me if you don't understand something. You understand me? So for example, you buy a car, you took a bank loan, and you want to pay off the bank loan. And what should be the yearly amount that you want to pay? Yearly amount. So you took the loan today, and 1 year later you need to make a payment, a payment, a payment, a payment. Could be monthly payment, it could be yearly payment. It doesn't matter. It's a term payment. So uniform series. So A is a uniform payments. Okay. So given the present value, find out the A, then you multiply with the present value at an interest rate for 4 years. So you know that's how you you did in the past already we already know it. Okay. So instead of making this one payment today, instead of that, you would like to make an equal payments. It is the same story. So this figure here is equivalent to this figure. Okay, 10 years. So today you are here. but you are taking the car without making any payment here. And then a year later, you pay that much money, another money, another money, another money. You're making payments equally. Same story, different voice, nothing else. So how many years is it? Actually 10 years. Don't forget that A is not in the year 0. A is not in the year 0. Suppose you make a down payment. So that means you have to subtract from the down payment from P. And then the remaining money that you want to make it A. You understand me? You want to make it A after subtracting the down payment. Right now, down payment is 0. You didn't pay anything in this figure. Okay? Is anyone has any question? Does anyone has any question? So you take the present value and make it equal payments. And that's 142.4 to take $1,000. It's clearly understood, right? Am I right or no? Salvage value is at the end of the period. You recover that money at the end of the period. End of the period is 4 years later here, right? First year, second year, third year, fourth year. 4 years later. The life of the asset here is 4 years. Is it clearly understood? And you can salvage it. I don't know. Can you confirm this one I posted on the web page or no? The lecture notes, this lecture note. I just wrote down a few minutes ago. To be honest with you, it was not really written down like this exhaustive on the slide. Is it clearly understood? Do you see this slide on your thing? Anyone confirm to me that I updated the lecture notes or no? Maybe more, maybe no. You tell me, then I'll post this. Otherwise, I'll leave it. It's okay still. So what is it actually? This slide is about John is a Uber driver. So what is he trying to do? He bought a car for how much money? Can someone talk to me? Just don't listen. Just reciprocate to me. That's when the Zoom is going to be more effective. Otherwise, I will feel like I'm teaching to a wall. At least, in a classroom, I see your faces. Even if you don't speak, it's a classroom, that's a different story. But here, you have to tell me, you understanding or you don't understanding. Hello? We have 21 people here in the class. None of you are able to speak with me. No?
It's clear.
Thank you. Thank you. At least I hear you. So, $50,000 you paid for the car today. Do you agree with me? Today you paid the car for $50,000 today dollars. And then the interest rate you're considering for the whole exercise is 10%. At the end of the 5 years, right? After 5 years, you're selling the asset for $22,000. You understand me? So which means that how much should you pay annually, cost point of view? Because this is the cost today. 50,000 is the cost today. Make that equal payments in 5 years. But the end of the period, right? You're getting $22,000. That is a future dollars, not today dollars, future dollars after 5 years. And you convert that to uniform series value and subtract them. And they get the answer. Is it clearly understood? There are 3 different ways you could do the same story. So one method is this way. I hope this is okay to all of you. No? If you say yes, I'll be moving to the next method.
Yes.
Thank you, sir. So you know what? Today you are taking $50,000. Do you agree with me? If you take 10%, you just multiply by 10%. What will you get? What will you get? You get the interest for each year. Do you agree with me? I will say interest for the first year. Do you agree with me? Hello?
Yes.
Yeah, you just multiply by 10%, you get interest for 1 year, one payment. Do you agree with me? That means you are getting interest for one payment. Suppose you pay that money. Next year, what will be the principal? Okay, I give you, you gave me $100. Okay, 5% interest rate. So you gave me $100. So after 1 year, I give you $5. I did not pay you everything. After 1 year, your money becomes 105, but I gave you only $5. How much money is left out with me? 100. So again $5, again $5, again $5, like a perpetuity, is like a annuity, is like a forever. You pay the same amount of money, the principal remains the same. Do you agree with me? If you're paying the interest amount for each year on the principal amount P, the P is going to move in the forward direction. Do you agree with me? It is the same P each year. Am I right or no? Do you understand this? Yes or no? Hello? Come on, guys.
Yes.
Tell me,
Yes.
So that means if you take 10%, so and then your first year is 10%, okay? You take that 10%. Every year you're paying the 10%. What is A? What is A? A is yearly equivalent uniform annual cost. So that's for each year. For each year, what will you be paying? That's what we are asking you here. $50,000 you spend today, right? Isn't it? So that means you are paying interest for 5 years. So that means 50% multiplied by 10%, that is the interest for 1 year. The same interest you pay, and then the P will go to the next year. And again, the same interest you pay, the P will go to the next year. And you pay the same interest amount. Okay, 10% of 50,000, how much is it? 5,000. Am I right or no?
Yes.
10% of 50,000 is 5,000. So that means you took the loan 50,000 today. After 1 year, you paid 5,000. How much loan is still there? 50,000. So go to the next year and then pay again 5,000. So how much loan is there? 50,000. So pay again 5,000. You keep on doing it. In the 5th year, how much money you need to pay? Because you're paying it interest, 5,000, 5,000, 5,000. So the 5th year, it is still 50,000. Do you agree with me? Because you're paying interest. So 5th year, you still have 50,000 to pay, but you sold your car and the car is worth how much? 22,000. So that means what you need to pay is 22,000. 50,000 minus 22,000 is how much money is it? 50,000 minus 22,000 is how much?
38.
38 or 28?
20. Yes.
28. So the 28 is a future dollar, not today dollar. It's a future dollar. For 5 years, after 5 years, that's the money that you have to pay it off. If you want to pay, $28,000 in the year 5, okay? All right. Also, you're paying A. 5,000. Also, you're paying A. So both of them you pay it off. Everything is paid off. But what you want to really find out is that 28,000 is actually, I want to pay it uniformly. I don't want to pay at the end of the year, end of 5 years, like a 28,000 plus A. I don't want to do that. I take that 28,000, convert to 5 years uniform. And that is this one. You understand me? And that means you need to pay the 5,000 plus, the final year, what do you need to pay? That I'm distributing together. And then that is a A. You understand this? Yes, no? Did you understand what I explained you? I can explain again if you wish.
Yes, maybe to repeat about 22,000.
Yeah, okay, all right.
I mean,
no problem. It's fair.
in
It's fair.
future,
It's fair. I will explain you until you understand. So this is a whole class is only this slide. If you understand this slide, the whole class is understood. Whole lecture class is understood. Okay, all right. Method 1 is easily understood, right? Am I right or no? Method 1. This one is understood, no? So you take the
Yes.
today $50,000 you're taking. You convert it into uniform series 5 years, A. You find out the A. And the terminal value at the end of the year, end of the 5 years is $22,000 you get by selling it. That is a future money. Okay. So you don't want to put that 22,000 in your pocket. You want to distribute that uniformly, and you don't need to pay 5,000. Okay. Instead, okay, for compounded uniform series for 5 years, it will be obviously more than 5,000 because you want to pay it off completely. It's not just permanent solution. It is just so that means you took that 50,000, converted into the uniform series of 5 years, and then you took that future dollars and then converted to uniform series. Subtract them. That's what you need to pay each year. You understand that? So in the second method, I'm going to explain you now. The second method I am explaining you now. You took the money 50,000 today. Okay. So year 1, you're paying A. Year 2, you're paying A. Year 3, you're paying A. Year 4, you're paying A. Year 5, you want to pay A. But the issue here is you have a salvage value coming back to you. So you take the $50,000 here. That's an expense to you. But the salvage value is coming at this point of time. 0, 1, 2, 3, 4, 5. At this point of time, you are actually getting 22,000 to your hand. Okay, you understand me? For your car, you are paying 22,000 to your hand. To you. You can put that in your pocket. Okay? Which means that, okay? So suppose you paid 50, instead of A, you pay 5,000. So that 50,000 goes to the next year, it is still 50,000 you owe. So that means another 5,000 you pay here. The P will go here. So 50,000 you still owe. You still need to pay. So you pay another 50,000, 5,000. The P will go to the year 4. The 50,000 you still have to pay. So, and then you paid 5,000. So you come here, you need to pay 50,000. Do you agree with me? 50,000. But for the year to come here, you need to pay 5,000 too also. You need to pay 5,000 plus you need to pay 50,000. So that 5,000 is a regular quota that you are paying every year. 5,000, 5,000, 5,000, 5,000, 5 times. You pay 5,000. And 50,000, you still owe them. But you are selling the car for $22,000. So which means that the money is coming to you, you can pay it off, which means that 50,000 minus 22,000 is 28,000 only you need to pay from your pocket. Do you agree with me? From your pocket, you need to only pay $28,000 from your pocket for the $50,000 car you got. Do you agree with me? That is a future dollar 5 years later. You need to pay $28,000. But can you take that $28,000 and distribute for 5 years? Yeah. So 28,000 multiplied by this factor. This is the future. And you need to pay that money as well as the $5,000. Do you agree with me? Did you understand me? You didn't understand. Yeah, thank you very much. So basically, when you are paying 5,000, the principal is moving in the forward direction. So every year you're paying 5,000, 5,000, 5,000, 5,000. 5 years you paid 5,000, 5,000, 5,000. And even in the 5th year, you still need to pay 5,000. You're selling the car for $22,000 and you effectively need to pay not 50,000, but 28,000 only from that moment onwards. And take the $28,000 instead of paying at the end, you'll pay it equally. So you need to another payment of that money, add them together is 5,000 plus something you need to pay, and you pay off all your 50,000, and you still took the 22,000 at the end of the salvage value, and also paid him off. You owe nothing after 5 years. So in the same way, you can also think. So end of the year, right? End of the year, end of the 5 years, you are getting how much money? $22,000. Do you agree with me? Hello? End of the
Yes.
period, you get the $22,000. Suppose you move it to the, suppose, you know, that $22,000 can be moved backwards. The money will become bigger or smaller? Will become bigger. No, sorry. In the number value, it becomes smaller, right? Isn't it? But actually, you are taking off. You know what? Today you have $100. 1 year later, it become 105 at 5% interest rate. You take 105 and you move it in the backward direction. It is only $100. So which means that you take, for example, $22,000, move it back to 1 year, okay? It will be less than $22,000. Do you agree with me? Because this 105 became 100 if you move it in the backward direction. But you paid off $5 though. That movement costs you $5. You have to subtract for $5 there from there. So which means that then only it becomes, okay? That means interest you need to actually, okay, consider that. All right. So that means $22,000. If you want to still back the $22,000, that means 10% interest rate is the equal series here. This is the equal money every year. 22,000, 10% is 2,200, right? 2,200. So 2,200 here is a 22,000. So 2,200. So if you become again, if you want to make it again to one more year, is 2,200. So you want to make it back again is 2,200. It goes in the backward direction. So each is worth of 2,200. This is the 2,200 every year. And then what happened is the 22,000, which is at the, at the end of the period, which actually came back as 22,000. So if you have 22,000 here, okay, that will become, today's money is worth more than, the future money, right? Okay. So that means it came to 22,000 today. Today dollars is 22,000. You subtract that. It's like a down payment of 22,000 today. So I take that money and equally distributed, okay, in the back to move it in the backward direction. So $22,000 I'm paying on top of the remaining here. You see? All right. Let me tell you one thing. Another way of teaching you the same thing. Let me teach you another way. Probably it's not really very clear to you. It's not very clear to you. I will explain you another way of doing the same thing. From the bank, you look $50,000. Do you agree with me? From the bank, you took the $50,000. Do you agree? All right. And then
Yes.
at the end of the 5 years, you are getting $22,000. Do you agree with me?
Yes.
End of the 5 years, you're taking that $22,000. Suppose I take a loan from somebody, okay, another person. I'm taking the 50,000 from the bank. I have a friend. I took 22,000 from him because I know that I will be able to get this money from for the every year I'll get, at the end of the year, end of the period, I'll get $22,000. I can pay it off at that point of time. Okay. So I took a loan from a friend. How much money did I take from my friend? $22,000. So 50,000 from I took the bank. I wanted to take the bank, but I don't take the bank from the bank $50,000 because I have $22,000. So I'll just only take $28,000 from the bank. Do you agree with me? So I only take $28,000 from the bank. I will spend enough time to explain you this concept. So $28,000 from the bank. So which means that I took a loan from the bank, $28,000. I took a loan from my friend, $22,000. Total is $50,000. The car is paid for. You understand me? The car is paid for. So I need to pay the interest to the bank, right? Is it not for 5 years? Do you agree with me? And also I need to pay to my friend. Okay. So 10% interest on the $22,000. Do you agree with me? Hello? I took a loan from a friend, $22,000. Don't I need to pay interest to him, 10%?
Yeah.
Yeah. So each year I'm paying my friend 2,200. So after 5 years, how much money do I have to pay to my friend? Every year I'm paying the interest to my friend. 22,000, 22,000, 22,000, 20. That interest, because I'm paying the interest, the money that I took, 22,000, is still the 22,000 year later. Again 22,000 year later. Again 22. After 5 years, I sell my car for $22,000. I pay to my friend $22,000. You understand me?
Yes.
And I took only the loan from the bank, $28,000. I paid it off in 5 years. Did you understand me? At least one of you understood. I'm happy. So I did not
Yes.
take the loan from one source. I took the loan from two sources. One source is the bank, $28,000. Another source is my friend, 22. I took $22,000 from him. Put together is 50,000. I bought the car. So I'm taking the $28,000, which I need to pay to the bank. I'm paying it equal amounts. Okay, for 5 years. That's what it is. This is what it is. But to my friend, right? How much money did I take, my friend? How much money did I take from my friend? $22,000. So what am I doing with my friend? I'm paying 2,200 every year for 5 years. The end of the 5 years, I still need to pay $22,000. So I sell the car and give him. I can sell the car for $22,000, give it to my friend. Is it not finished? Did you understand me then? Can someone explain what I told you?
You're saying if you pay only the interest part,
Yeah.
the original part later we can pay, and the loan would be paid fully.
Yeah.
Yeah.
Perfect. But there are two loans here. One loan is from the bank, which is $28,000. Another loan is from a friend, which is $22,000. So for $22,000, I'm only paying the interest, not the full amount, only the interest. So which means that the $22,000 will remain $22,000 year later, year later, year later, year later. So after 5 years also, I need to pay my friend $22,000, but I sell my car for $22,000. I pay it off to my friend. Whereas I took the loan from $28,000, I need to pay it off in 5 years. At the end of the period, 5 years, I don't need to pay any more to the bank because it is distributed in 5 years. So it's paid off. Did you understand? You do any three of them, the A is 9,586. You want me to do it or you can do it? It's just a computation, nothing else. You know the factors, right? Isn't it? A, P, 10%, 5 years. Just multiply that. A, F, 10%, 5 years. Multiply that. So you know this, right? Am I right or no? Did you understand this? Yes, no? You want me to explain you again? The entire story is only this. The class is done. If slide is done. The entire slide is only that. Nothing else. The entire class is only that. Come on, guys. You have to tell me because it's a very interesting story, actually. I explained you easily. I
I
assume
understand.
I assume I explained you easily.
Yes.
Because you know what? You take the 50,000 loan and distribute for 5 years, and then take the 22,000 loan of the future money, distribute to 5 years and subtract them. That's what you take, make the payment every year. Okay. All right. That's what you make payment every year. That is first one is easy to understand. Am I right or no? First one is not difficult to understand. I hope it is easy to understand. The second one and the third one may be difficult to understand for you. But even if you think that a little bit smarter, you will understand easy. How, sir? So I took 50,000 loan. So first year I pay $5,000. Okay. And then the loan is still 50,000. The second year I pay another 5,000. The loan is still 50,000. Even if you go to the fifth year, the loan is still 50,000. So every year I'm paying 5,000. So that means 5,000 I'm paying every year. Okay. This equal payment you are finding out for each year. So this 5,000 I'm paying as an interest to that, right? Isn't it? But at the end of the period, you still need to pay 50,000, but you need to pay all of it in 5 years. So that means $28,000 here. That is a future dollar you need to pay. So you want to pay it off in 5 years. So you need to add that. So the 5,000 plus whatever you're going to pay here, that is, I think this 4,586. This whole thing, right, is 4,586.33. And add that together is 9,586.33. That's how you get. So another way to understand the same story is because end of the period, the salvage value is $22,000. I take that 22,000 today and subtract it right from the 50,000 and distribute that equally. And end of the period, $22,000. Okay, you have been paying it every year, 2,200 every year. You're paying that 2,200. So that means every year what you're paying is the interest on the $28,000 for 5 years, not interest, equal payments, uniform series value, plus the $22,200 you pay. So end of the period, it doesn't go any further because you take the salvage value and pay it off. I hope you understood it. If you don't understand, you can think of, I'm taking the loan for $28,000 only here. Okay. And convert that to $28,000 present dollars as uniform series value. Okay. And I take a loan from $22,000 from my friend and I'm paying $2,200, 10% interested every year. So after 5 years also, I need to pay only $22,000 to my friend. I sell the car and pay it off. So this is the equivalent uniform annual cost. So P multiplied by this factor minus S multiplied by this factor is the first method. P minus S. Okay. Is the future dollars. And you want to convert to the uniform series, and every year you're paying PI. So add them together. Second method. The third method is take the SI, which is the future dollars, right? Isn't it? And then subtract, bring it in the forward direction, and that is today's money. And then you actually convert both three, method 1, method 2, method 3. There are 3 methods I did work out in the previous slide is exactly the same. So you take a student has taken a loan here, $10,000, $1,000, 7% interest rate. Okay, he believes that furniture can be sold at the end of the period for $200. So end of this is the salvage value. This is the N. This is I, interest rate. This is the P. So you have everything. You want to find out the A. So you take the A. So either any of the method you can use to do that. Take the P and convert into 10 years uniform series value minus, take the $200 and make it uniform series and subtract it. You get it. This is method 1. Exactly the same way you did 127. So this is method 2. So they take the PI, I think, yeah, P minus, yes, right? So, I wrote down the formula in a different way, but you can understand this way too. This is the formula. So PI, you're paying the principal amount, the interest, which is PI. So even after the 5 years, it is still the P, but you are getting S at that point of time, and you subtract that, and then convert that to uniform series, add them, and then you pay it off. That's the same thing. Whatever way you do, you get the same answer. That is method 2. Method 3. So this is the formula. You took the salvage value, bring it to the forward direction, and you subtract it, and then you make it a uniform series, the present value and SI. Either way you do, you get the same answer. I hope you understood it. So equivalent uniform annual cost information is very important to understand this. Fixed input, fixed output, different situations may happen. Okay. So amount of money or input resource is fixed. Okay, fixed input, fixed output. Neither input is fixed nor output is fixed. Then you need to work it out. We'll look at the examples. That'll tell you rather than understanding the theory. So you have 2 options here. Okay. So 2 options, both of them, the useful lives are only 5 years. So both equal amount. So no salvage value. Okay, no salvage value in both cases. So equal lives, 5 years only. You don't need to worry too much about it. So today this is costing you $1,000. Today it's costing you $5,000. You understand? $1,350. Okay, but it is expected to result in the savings of $300 annually. Okay, and no salvage value at the end of the thing. You understand me? So each year the saving is $300. You understand, right? But you are actually paying $1,000. So take the $1,000 and convert it to equal payments, which is A. But each year you're getting $300, you pay it off. So which means that, so this is a negative dollars that you want payments, is positive dollars, is your revenue coming to savings coming in, is accounting it. So actual uniform, actual worth of it could be negative or positive, whatever it is. Actual worth, what comes in, what goes out. So in minus out is $56. You understand me? That is your savings, not a cost. You pay $1,000, but 5 years, not only it paid in, but also saved you $56.1. So device B, the same story, but a different thing here. There's a gradient, $50 annual increment. This is a gradient of $50. The arithmetic gradient. So it starts with 300, it becomes 350, 300, 400, like that it becomes for 5 years, right? So you can even draw the figure. So how do you draw the figure, sir? So this is minus 1350. So after 1 year, the saving is 300. After 2 years, the saving is 350. So our 3 year is 400. And 4 year is 450. And a 5 year, and that is 500. This is a 5 years, right? So that means this figure can be divided into, okay, 2 different figures. So that means the positive things I'm writing down 300, 300, 300, 300 like that. That is A, which is 300 only. That is 300. The 50 is a gradient. You understand me? The 50, 300 here, sorry, 300. The gradient is here. So that is $64. This is a positive value of 64. This is also a positive value of 56, which means that I will prefer B, the device B. Is it clearly understood to you? Yes or no? You don't understand, please ask me. No? Yes? Okay?
Yeah, it's okay.
Okay, no problem. Thank you very much for
Maybe
letting
to
me know.
calculate some
Yeah, but
exercises.
multiplication, I'm not really worried about. I want you to understand this. You want to find out that factor, you go to the table and find out the factor, right? Isn't it? Okay, now the 3 alternatives you have here. You want to make a decision. Okay, so there are 3 options: plan A, plan B, plan C. You have. So that means you're buying an equipment for $50,000, $15,000, or $25,000, or $33,000. You understand me? So improvement operation in the assembly along with the do nothing alternative. So that means you have a do nothing alternative. Where is my do or nothing alternative? So A, plan A, plan B, plan C for 10 years life and a scrap value of 10% of the original cost. So 10% of the original cost of 15,000 is 1,500. Original cost is $25,000. 10% is 2,500. So the 10% of the original value is this one. You understand me? And then annual operating cost. Every year you need to pay for operating. You understand me? Every year, that much money for operating. Okay. Material and labor cost, labor savings. This is savings, not expense per year. That is $14,000 savings. This is $9,000 and $14,000. And installed cost of the equipment is the money going out $15,000, $25,000, and $33,000. And the interest rate is 8%. For 10 years, you want to evaluate. Okay. Which plan is better or something? You understand me? Okay. So, all right. You want to convert this into the different ways of looking at it, right? Isn't it? Okay. So material and labor savings is $14,000, right? Isn't it? This is annual savings per year. Is savings. Okay. So but annual uniform cost, right? No, 8% is okay. And I'm actually writing down, all right. Okay. I'm going backwards here. I think I gave you here, the number I gave you here. Look at that. This 15,000, sorry for that. I just go back again to place where I was. Okay, here. So the cost of the equipment is how much here? The plan A, plan B. Come on, sir. What is going on? So, okay, all right. I go back again. This time I will be very careful. Okay, tell me now. Okay, so the cost of this plan is how much? $15,000. Do you agree with me? The cost of this plan is what? $25,000. Do you agree with me? Cost of this plan is what? $33,000. That's equipment, right? You're buying it, the installed equipment that you had before, the installed equipment that you have here. So you are actually paying off today, right? Am I right or no? Today. So you take that today, $15,000. Okay, 15,000 or yeah, 15,000. Okay, all right. So you take the $15,000. How much is the for 10 years, right? Is it not 10% of the original cost? And scrap value equal is 10% of its original value, right? Isn't it? That's the money coming back to you. Do you agree with me? The scrap value is coming to you every year. Do you agree with me? $1,500. Okay? Money coming to you. Am I right or no? The $1,500 is coming to you. Am I right or no? You spent this $15,000. So $1,500 is a scrap value. This is a future value. Do you agree with me? And then you want to convert that uniform series for 10 years, 8%. That's also money coming to you. Every year your money coming to you is $14,000 plus the scrap value is coming to you. So effectively you are getting money 14,104. Am I right or no? You can do the way you want. I don't need to sell a method. This is the way you do. You can do the way you wish to do. But I'm teaching you one way of doing it. All money coming in is like a benefit. So equivalent uniform annual benefit is 14,104 because every year you're getting 14,000. So material and labor savings, that is $14,000. So end of the useful life is $1,500. That's also money coming to you. With 8% equal 5 year, 10 years is 104. So add them together, that's the benefit. You understand me? Yes or no? And if you're looking at the installed equipment, which is $15,000 is the money going out. Okay, $15,000 is the money going out. That is how long? 10 years, 8%. The factor is 0.1490. So multiply that equal amount is $2,235. The $15,000 is equivalent to $2,235 uniform series value. And also operating expense is another expense. Add them together is 10,200. This is the expense going out, money. So the difference between the benefit and the cost is 3,869. And do the same math for all of them. Okay. So plan A is the better thing. Do you agree with me? Do you understand me? Can someone explain this whole thing? If you understood it, you will be able to explain me. One plan you explain me, I'll be very happy. All the numbers I put in, you explain me, I'm happy.
I can.
Yeah, go ahead.
So we're calculating A for each. So for the material and labor per year,
Yeah.
that would be a saving of 14,000 per year. Also, another thing that counts as saving is the salvage cost. So
No, it's not salvage cost, it's salvage value because
it's
money coming
salvage
back
value.
to you.
Yes. So it is a saving too. So
Yeah.
we would calculate it with A over F, as it is a future.
How much is future
payment.
is $1,500. Yeah.
Yes, 1,500, which would become 104 per year.
Perfect.
And for the costs, we have two costs. The annual operating cost, which is 8,000 per year, and the installed cost from the original price,
Yeah.
which we calculated with A over P, as it is present
15,000. Yeah.
money. Yeah, 15,000 is the present, which becomes 2,200 per year.
Perfect. And then add the total cost and the total benefit. The difference between this total cost and the total benefit is 3,869. You do the same math for each one of the scenarios and then compare them. So the plan A is the best, which is 3,869 is the savings, whereas plan C is the next best, which is 3,311. So plan B is the worst because you're losing still more money. You're not getting anything back. So it's not paying off. It's still losing money for you. So that means plan B is the worst case scenario. Okay. And plan C is a better than plan B, and plan A is the best. Thank you for explaining very clearly. So equal lives, unequal lives, sometimes, right? So when it is equal life, unequal life, infinite series. So infinite series, for example, cost can be infinite, benefit can be infinite. So like, P multiplied by I, remember, you give a P, you give me $100, for example. Okay, give me $100. And I will pay you each like a 5% interest rate forever, 5%. So amount A I'm going to give you is P multiplied by I, which is going to be $5 each. So every year is $5. I'll come and give you $5. Next year I'll give you $5. Next year I'll give you $5. So whenever at any given point of time, after I give you $5, if I give you $5 and ask you how much money do owe you $100, it is still the same. It is forever. To pay off completely, I have to give you just $100 and the interest at any given point of time. Meaning every year at the beginning of the year, right, or at the end of the year, I need to come and give you $5. If I want to pay it off, I give you 105 and that's it. But I don't want to pay it off. I have to give you just a PI. N is infinity. P remains the pay. P remains the same. So there are two options here. Tunnel through a mountain and a pipeline through a mountain. Okay. So two alternatives here. This is a permanent solution. If you put a tunnel, for example, is a permanent solution. Okay, useful life of the whole story here, right? This one is a permanent solution. And this one is a 50-year solution. Every 50 years, you have to do the same. Permanent. Can you make the 50-year permanent? Yeah, you can make the 50-year permanent. How? So you take the uniform value and that can be, that means pipeline. After 50 years, you do again another pipeline, you pay another pipeline, another pipeline. You keep on doing the same thing forever. So you take the 5 million and make it, 50 years, uniform, like a 50 years. And then you get the A for it. So 5 million you take, equivalent amount for 50 years, taking the 5 million as the principal amount is 317. This is forever. Why forever, sir? After 50 years, okay? So you're paying every year. You build the pipeline here, and it is only good for 50 years. So after 50 years, what will you do? You'll put another pipeline, another 5 million you spend. Doesn't matter. You again still will pay 317,000 forever. So again, another 50 years later, another pipeline, another 50 years later, another pipeline. So what is the difference between the previous tunnel and the pipeline? The same, because that is forever. This is also forever. So, but the cost of the tunnel forever was $330,000, whereas the cost of the pipeline is 317. This is the cost. Which one is better? Pipeline. Did you understand this story? No? So I will close it. I think by this time in the classroom, I actually complete the story. So another 3 more minutes, I think I'll be able to finish the story. I know not 3 minutes, sir, 1 minute only. Okay, all right. So I already explained you this. For example, the difference between the annual cost, the long life and infinite series is normally small. So $330,000, you see? So the example in the previous slide, which is giving you, okay? So 330,000, 6% is 330,000, that's forever. Long life is 50 years long, 85 years long. If it is 85 years, for example, And the same amount of money, the difference is very small. Look at it. It's only $2,000. $332,000 and $330,000 is deceivingly very small difference. 85,000, 85 years, is it infinite? No, it is not infinite. It is 85 means 85 years. After 85 years, you still need to build. But the time value of the money changes so much. Okay. What is 2,000 every year can get accumulated so much money in 85 years. You wouldn't believe it. The cost of a car was only just $500 when Henry Ford actually designed an assembly line to manufacture cars. The cost of a car was how much money? $500. But today, the cost of a car is almost like $50,000 or $40,000, at least $30,000. So the formula that I gave you here is three formulas I gave you here, right? Remember the three formulas? I explained you again and again. PI, SI, move the S in the to the beginning. So move the, P to the end. Okay. And the P uniform series, S uniform series. This is a very interesting story, which I explained you very detailed. And the difference between equal lives, right? So, and also explained you. That's all the story for today. Is it clearly understood? Yes, no? I hope you understood. So that's it for today, and I'm stopping. And I'll post this on the web page. So next week classes will be in the class, not on the Zoom. Okay, bye now, all of you.